So welcome to our SAP BTP Advanced Trading, and this is the day 20. This is the official final session of our SAP BTP Advanced Trading. Today's topic is very interesting, and it may help you to navigate to your next jump or next journey, okay, beyond BTP. So what is that? So we'll be learning more and more from other technologies, other solutioning as well, right? So like what we will be learning today. So let's understand first in a roadmap format. Okay, so in our roadmap, we'll see today. So we'll see, let's say like this is your road. Okay. So anyway, so whatever. Here we'll be learning different technology, okay, today to reach SAP BTP Kyma. Okay. So when we are talking about SAP BTP Kyma, it is all about like containerization, Dockerization, Kubernetes, and so many other things like microservice and serverless component. But before jumping into those Kyma-based application development, we need to understand the baseline. We need to understand the baseline framework or baseline technology. Okay, what are those baseline framework and technology? So those are basically like the container, as I was mentioning, the container and like the Docker. So these are the different roadmap milestone that we will be achieving today. We'll try to achieve today. And finally, we'll be reaching to BTP Kyma. So basically what I'm trying to say here is we'll be starting with the container. Then we'll be moving into the Docker. Then the Kubernetes. The Kubernetes full form going forward, I'll be writing it as K8S. And finally, we'll be seeing the Kyma. And in the Kyma environment, we'll be mainly focusing on the serverless. So this is our roadmap for today. And before moving into those, even like containerization or Dockerization or Kyma environment, so we need to understand why we are learning that environment as well. So what are the things that we have learned so far as part of the platform or as part of the deployment component or as part of the uh, app running engine or the application environment, okay? So let's understand that as well now. So far we have learned in SAP BTP, we have learned the Cloud Foundry. So we have learned a lot of techniques, or we have learned how to do the coding in Node.js, in CAPM, CDS, HANA Cloud, and we were able to deploy efficiently in Cloud Foundry. So when we were dealing with the Cloud Foundry runtime, so there also we have seen the containerization concept. So if you remember in our earlier level 1 and level 2 training, so there also we were learning this architecture of this SAP Cloud Foundry runtime. So there also we have seen the Guardian container, right? So containerization concept was there in the Cloud Foundry as well. But we were not so much bothered about that because the Cloud Foundry runtime helps us to abstract from all those kind of like technical components so that we can mainly focus on the business logics and we can write our code logics in our CDS, in our Node.js, in our CAPM framework, and we can easily deploy. And whatever the things that we were mentioning in our deployment descriptor, it's like our runtime would be Node.js, our runtime would be Java, our runtime would be Python. Based on that, when we will be doing the CF push, automatically it was generating the container and it was handling all the components. So there also we were learning the microservice based architecture, right? So similarly, like here, so what are the other runtime that we have? We were learning like, okay, so we do have another runtime that is called as ABAP runtime, right? So let's say ABAP is the number one runtime. Although we were not learning ABAP. So the reason is why we were not learning ABAP, because we wanted to learn the microservice based deployment, microservice based architecture design. So as because ABAP runtime is not a microservice, it doesn't support the microservice based architecture. So that is mainly built for monolithic kind of like software design. So all the component you are putting it into a single component, and from there maybe like you can modularize the things. You can have like, okay, so different function or API calling, like that you can actually manage your code bundle. But that is not a microservice based design. So that is mainly for monolithic based architecture, monolithic based design. And in the Cloud Foundry, we heavily learned about the microservice based architecture and design, and we were successfully deploying a lot of complex project in Cloud Foundry runtime, especially with the CAPM and Node.js. And today we are now seeing another runtime, that is the Kyma. So Kyma, this is the particular technology which is based on containerization concept, which is based on the Kubernetes concept. Okay, what is this containerization? What is this Kubernetes? Those are the things we will be learning first, and then we will be moving into the Kyma runtime in SAP BTP. So, as I was mentioning, so Kyma is based on the Kubernetes, which is also based on like container. Okay, so the basic component of Kubernetes is the container, and also we can also do the serverless kind of deployment. What is the serverless? What are the benefit of the serverless? How we will be actually deploying our application as a serverless component in SAP BTP Kyma environment? Those are the things we will be learning today. So serverless. So serverless means you can. So it doesn't mean like serverless. It doesn't mean like there is no server or there is like, okay, there is no machine. But definitely there will be machine, but how efficiently we can utilize the machine, the container, those are the things will be coming into picture to reduce the cost of the overall IT deployment or the software deployment. So those are the things we'll be learning in this serverless component. Okay, so I think like we have the context setup now. So what we'll do is we'll be mainly dividing our today's episode into probably three sections. Okay. So in the first section, we'll be learning the container and Docker. Okay. So as a container and Docker, like it's not like SAP specific, it's generic. And even the similar technology you can apply in SAP Kyma environment as well. But if you go beyond SAP, you will be learning or you will be seeing this container and Docker based deployment everywhere. Okay. So first section, we'll be learning the container and Docker. The first section, we'll be learning the container and Docker. And the second section, we'll be learning about the Kubernetes. And the third section, we'll be then going into the Kyma environment. Okay. So let's start. So let's start the first section, that is the container and Docker. Okay. So what is this container? Why we are so much bothered about this container concept? Because of the microservice based design. So we wanted to independently handle different software component or different processes of our application, so that like the deployment process, the dependency will be reduced, and also like maintenance cost will be reduced. So those are the benefits that we have while designing, writing code in like microservice based architecture design. So those are the things that we have learned so far in our earlier sessions, the concept of microservice. and we have developed even different components inside microservice, like the API microservice, event microservice, database microservice, and so on and so forth, right? So, so then what is Docker? Okay, so, sorry, what is the container? Container is like, so if I give some live example, let's imagine, so let's imagine some problem statement, okay? So problem statement, or what are the problems that we are solving here? The problem to solve, okay? Problem to solve with the Docker. And when we'll be talking about Docker, generally I will be actually giving this particular icon. This is the Docker icon. If you have seen earlier in any over in over the internet, so this is the Docker icon. This particular icon that I will be drawing in each and every slide. Okay, wherever I will be explaining Docker. So why Docker? Why container? Because let's imagine one live example, in real life example. Let's say like you're shifting your rented house from one house to another house, right? Then what you need to shift all your necessary equipments, right? Or let's say like furniture or whatever. So TV, furniture, whatever the component that you have in your rented home. So you wanted to ship it to one place to another place. So if you ship it like separately, okay, so separately, then probably there are probability like you will be missing out some of the components, right? So what we generally do is we generally hire a container, okay, so like so or tempo or something like that, right? And we generally put all our component, all our necessary accessories there, and then we ship from one home to another home. So basically, what I mean to say here is like, so let's imagine the similar concept in software component or while building any application. Let's say like you are building any Java application, or maybe like you are building Python application. Okay. Or maybe so whatever MySQL with MySQL database. Okay. And maybe let's say like all this component is running on top of the Nginx component, Nginx server, right? So what happened? So we do have different components. So to move all this component efficiently, let's say like you are building application in your local machine or computer where you have installed Python version, something like some version, or you have installed some Java version, or you have installed some MySQL version, right? So based on that, if you are building a application and the application is running smoothly in your local environment, in your local machine, it is not necessarily will run the similar way in some others machine, right? Let's say like you wanted to give this entire software to your customer, or you wanted to give this to your peer developer so that they can develop some of the other component as well. So there are chances like they will be installing, if they wanted to install by their own, they can install the different version of Java, the different version of Node.js, whatever. Okay. So in that way, it can be, you can face the incompatible issue, right? So for those kind of like issues, to avoid those kind of issues, we can, what we can do is we can containerize. Containerize means like putting all the components in a single box together, and we can, instead of shipping the one by one component or one by one microservice component, let's say like Java microservice component, database microservice component, Nginx microservice component from one environment to another environment. Instead of that, if you put it together in a single box, and then you can ship it to the other place, so you don't need to reinstall the different component. So the versions will also be intact. So all you can avoid all those kind of like unnecessary things. Okay. So this is one of the benefit, definitely. And another benefit would be like we have seen. So before moving into the other benefit, let me just tell you some of the concept, like this kind of concept, this particular containerization, or like boxing your software, or efficiently managing your microservice component. Previously, we used to use the virtual machine. So if you have observed, like in our previous learning, previous level 1, level 2, there also we were trying to differentiate what is virtual machine, what is container, and why we are shifting from virtual machine to containerization technique. So those are the things you have learned there. But so to refresh those things again, so I'll be taking the similar example. But before that, let me just draw it out, like how actually the software works on top of our uh, machine, or on top of the OS or our computer, right? So let's imagine like you do have this hardware. So let's imagine like you do have this particular hardware component. So their hardware means you have the CPU, you have RAM, you have hard disks. So I'll be drawing the hard disk like this everywhere. So these are the this is the hardware component that we generally have in our machine to run any kind of software. And on top of that, so software will not run directly inside the hardware, right? So we need some OS, operating system. On top of that, we can install our software. Let's imagine like this is your OS. But the OS is also having two components. Okay, so OS is also having two components. What are the two components that we have in OS? In OS, we do have the OS kernel, so which generally talks to the hardware directly. But there are other component of any kind, anyways. Okay, so be it Windows, be it Mac, anyways, there are generally two components. One is the kernel component, another not component, layer. Okay, so there is two layer. The lower layer is the kernel layer, which directly talks to the hardware, and there is another layer on top of which we generally put our or install our software or our application. So that is, we call it as OS application. Application layer. Okay, fine. And where we generally install our different software, let's say like Microsoft Word or Outlook or whatever, the micro or Chrome browser, whatever. So let's imagine this is, I'm just copying the similar component once again, just to give you differentiation between the virtual machine and Docker container. So let's imagine this is the Docker container, and this is the virtual machine. So what generally happens, so we can avoid that particular situation, like putting all the component together either in virtual machine or in Docker, and then we can shift it from one place to another place, or maybe like from our development environment to quality and production environment. Like that, we can ship our software. So there are two options: virtual machine and Docker will work. So technically, it will work like in the similar way. Okay, to solve the same problem. But if you go into the deeper mode, you will see. So while you will be actually installing or using a virtual machine on top of any hardware, so it is not like, so while you will be installing like virtual machine, it has its own ways, right? So we have to use the whole ways and then install it in a particular hardware. So let's say like for this particular piece, we do have to install the OS, the whole OS, like with the kernel layer and the application layer together. and we can install this particular virtual machine, and we can put our different software component inside this, and we can ship it from one environment to other environment, or we can ship it to other developer, or we can give it to the our customer. So that is like the process happens generally in the virtual machine. But in case of Docker, we do not need to reinstall the OS kernel. So what it will happen, like while you'll be installing the container concept, like only the OS application layer on top of the existing operating system, which is running on top of the hardware, we will be using and installing the separate application layer, OS application layer itself. Okay, so we'll be only dealing with this component. So we will be only dealing with this component. So in this way, what will happen is, like, the first benefit is the size. Okay, so VM size and container size will be different. So will be different in this particular way. Okay, so if you wanted to put your all microservice component in a VM, the size will be huge. You cannot reduce the size in terms of like megabyte or gigabyte. Okay, so let's imagine, like, if you are using the Docker, you can confine your software within some megabyte itself. But if you are using virtual machine, you probably need to go gigabytes, multiple gigabytes. Okay? The size is one of the biggest factor. And the second factor is like the performance. Okay, so while running or booting the virtual machine, it takes some time. Okay, but instantiating or booting or running the Docker container, so it, as because this is a lightweight component, so the timing will also be less. Like the performance will be good in Docker container, and we'll also learn, like, okay, so putting the different component together in a virtual machine, probably we cannot fully achieve the microservice based architecture. So those are the things we'll be learning in subsequent topics. But as of now, I'm giving you some example, like there we can give the Dockerization. Okay, so while we are saying container, so like let's say like container means uh, you can put a particular software component, microservice component in a particular container, okay, or particular Docker container. So if you have multiple, let's say like you have let's say so you are having like, let's say like uh, web shop or something like that, right? So e-commerce platform. So there you do have different component, like okay, the customer query, the product listing, or add to cart, or payment, or notification, or for different functionalities, we generally build different software component that we are calling it as a microservice component. And if you wanted to efficiently put together in a single, if you wanted to efficiently work together with those microservice, you can use to put the different microservice component into the different Docker container, and then different Docker container can talk to each other with a specific mechanism. Okay, those are the things that we'll be learning. So that means like the microservice based architecture can be easily designed in the Docker container based approach compared to the virtual machine. So microservice based design can easily be achieved in the Docker container. And the fourth differentiation would be the cost, as I was mentioning. So, as I was mentioning, the initial running cost, or the component cost, like you are dealing with only the OS application layer component. So those are the reason, and let's say like this, the sizing will also be reduced in the Docker container. So for all those things, right? So you can imagine like the cost will be also reduced in the Docker container based approach compared to virtual machine. So that's fine. So I'll be moving a little faster. Otherwise, like there are a lot of things that I need to actually tell you. That's the reason I'll not uh, give you some pause, but definitely I'll be giving you the open floor at the very end of this particular session after all the sections. So as of now, let's go into the Dockerization concept. Okay, so as of now, we understood theoretically like to have the microservice based architecture designed efficiently or running efficiently in our production environment. Docker container is the ideal mechanism or ideal place or ideal tool that we need to use for our application deployments. So now let's move into some more detail of Dockerization. Okay. To move into more detail of Docker container, so we probably need to understand three main components of it. Okay. So just keep in mind all these three components as of now. Gradually, you get to know why we are using those components and what are the benefit of those component and how those components will talk to each other. So first component is the Docker file. Docker file. Okay. So this is the first component, and second component is the image. And the third component is the container. So what is this Docker file? Docker file is a kind of like blueprint. Okay, you can imagine kind of like as a blueprint for to run your software. Okay, so blueprint means like you are defining all those configuration details, how your software will look like, what are the component it will the baseline component it will be using as a final software. So those are the blueprint. So basically what I'm saying is Docker file is the blueprint. It is like a blueprint. And then on top of this blueprint or using this blueprint, you can build the image of the software, image of the container. Okay. So then using the blueprint, all the configuration details, you can build the image of the container or image of your software component. Okay. So basically like image means, let's say like, imagine like this is the image. And when, so what is it then image? Image is kind of like, you can imagine this is kind of like template to run the container. And container is the running component, running process of your application. Okay. So template. And I was mentioning this is so using the template, you can run your software, different microservice as a container. Okay. So this is the running process your software. Okay, just hold on for a few seconds and just put this in your mind. Docker file is the blueprint where we are defining different configuration details to build image. Image is something like a template, which we can place it to any kind of marketplace or any kind of registry. And we can then pull that particular image in any machine, be it like cloud machine, local machine, to run the whole software as a container. Okay, fine. Now the next component would be, after understanding those Docker file, image, and container, which is a running process of your software. Now let's understand few of the other components, or it's better, I think, like to go into some practical mode, do some hands-on, so that you will understand the things better. Okay. So before going into the practical mode, probably like, okay, so we need to download some of the tools. Okay, so what are the tools? Let's say like we need to download first Docker desktop. And then probably we'll be building a project. Okay. So first of all, first thing is probably first thing is download. First download. I'm just putting all the components in a written format as well, so that when you will be practicing the things, you will get to know what to do now or what to do next. Okay, so first of all, download the Docker desktop. So what is Docker desktop? Okay, so let me just tell you what is Docker desktop. Okay. So what you can do is, first of all, as of now, Docker desktop is something like you can imagine where you can actually develop your this component. Okay, so these are the component that so you will be developing. You can develop your component in a local machine like Docker file and then image, and then on top of the image you need to run the container, right? So to run the container in a unified environment, right? So we are trying to standardize the environment, right? Software environment, right? So that is the main motto we are actually having with this Docker container, Kubernetes and all, right? So how to standardize the running process of your software? For that, to mimic the similar thing in your local machine, you need this component, Docker desktop. Probably you will get to know some more concept when I will be actually doing the things in Docker desktop. So let's go inside the Docker desktop and first of all download it. Okay. So if you will go into this Docker desktop, you can download Docker desktop based on your operating system. So let's say like you have Windows, you can just go here and you can download it, and then probably let's say like I'm downloading it here. It'll take some time. I do already have the Docker desktop. So after this, you just go inside. This is a exe file, so it's a click thing and finish. Okay, it got successfully installed now. Now we can move forward and we can see what we can do. This Docker desktop. Fine. Okay, so now again, if I will just search Docker desktop, it's appearing, it's coming up. And to use this Docker desktop, as because we learned some other component here. First of all, we were learning. So Docker desktop means it will be running the container, right? So as the description was also saying, it will be running the container. Set. Docker engine is the underlying technology that runs container, right? So to run the container, we need the image, and where we can actually put the image so that like anyone else can download it or anyone else can pull it. So for that, we need to have a count in Docker Hub. Okay. So if you go to this hub.docker.com, you can register for free. Okay. And then you sign in. Like I'm signing in with SAP BTP training, gmail.com. Continue. Okay. So this is my dashboard of my Docker Hub. So where I already put some of the images. You can see some of the images. When you will be actually logging in, you will see nothing is there at the first time. Okay. So and then you have your credential detail as well of your Docker Hub. What you can do is from your Docker desktop, then come back again to the Docker desktop, and then from here will be having the login option. My account got automatically logged in as because previously I was logging in. So like this, you will be seeing account setting. It is opening the Docker Hub itself. Anyway, so I was just trying to show you that from Docker desktop, you need to first log in to the Docker Hub. Okay, so that you can put your images to the registry. So you can imagine Docker Hub is the registry. So you can imagine Docker Hub is something like in your GitHub also, right? So in your GitHub also, you first develop your code in the Visual Studio Code, and then you push it into the GitHub so that others can pull it from there. So similarly, while we'll be actually building our Docker component in our local machine, first of all, we need to put it into our Docker desktop. We need to put it into Docker desktop first. And whenever we have the Docker desktop, whenever our images will be there in the Docker desktop as a running component, then we can actually push it into the registry like Docker Hub or anything else from where anyone else can actually pull in. Okay, or not anyone. Let's say like you wanted to pull the same image to your quality environment or production environment, you can also pull the same image, and then you can run it in your quality environment and production environment. So like this, it actually works. So I already logged in to my Docker desktop to via my Docker desktop to the Docker Hub. Okay. So here also we do have different components. You can see here we do have the container, we do have image, we do have volume. We're learning all those components gradually. And the first thing, so image, we have some understanding of image and container as of now, right? So from this component, like what is the image and what is the container. So let's first build it. Okay. So to start the building, we need to have the Docker file. So what we have to do, put the Docker file. So whatever I'm teaching today, it's not like I'm teaching some kind of like programming language or script like we have done the CAPM framework or Node.js or HANA Cloud based development, CDS based development. No, right? So here we are trying to understand how to standardize, uh, uh, how to standardize the software development or software deployment environment, and how to efficiently manage the microservice. So those are the things we are learning today with this Docker, container, the Kubernetes, and even Kyma. Okay, so those are the deployment platform. Okay, or deployment runtime. So let's first go inside now this Docker container. And first of all, as I was mentioning, so as because we have to develop the things in our local machine, we will not use the the BTP based business application studio. We'll be using the Visual Studio Code. So I think Visual Studio Code, you already have it in your machine. If you have latest OS. Yeah, please mute yourself. Okay. So what I was telling is like let's build a simple application, then try to dockerize it as a container, Docker container, and then push it into the registry, the Docker Hub. Okay, so those are the things that we'll be learning now. So what we are trying to learn, like let's create a basic Node.js in a VS code, Visual Studio Code. Okay, in the Visual Studio Code, in your local machine, you create a Node.js based application, and then with using the Docker file, build the image, and then run the Docker image. Please mute yourself. Let me mute all. Okay, fine. So after having the image, so this concept is very important. Based on this, if you have strong understanding of this particular concept, you can easily build any kind of container. And when you have the image, then you can run that particular image inside the Docker desktop, okay, as a container. Okay, so then we'll be running inside the Docker desktop. Or let me just put it like this. This image, right? So, and on top of the image, you are running the image in your Docker desktop. As a container or multiple container. If you have multiple components in your software, your application, have the microservice based design, and then you can actually uh, push the Docker image, or maybe like this will be like this. You can push it to the Docker registry, like the Docker Hub. Okay? And from there, anyone can actually pull it. Okay? Anyone can pull it, like any other developer or any other environment, whoever you wanted to actually share, they can also pull it from the Docker registry. This is the component that we are learning now. So first of all, we have the Visual Studio Code. If you do not have Visual Studio Code, you download it first. Let me just open the Visual Studio VS Code. And what I'll do is I'll be creating a new, like new cloud code. So I'm just dragging and dropping this particular folder here so that I will be having a new workspace. Okay, no, sorry. I first of all wanted to have a new workspace. Let me run this. Close first. Previous one, a blank workspace, and here I can drag and drop my folder so that I have my baseline. And what I'll do is I'll be terminal. So I am here in this particular directory, 𝐂𝐞𝐫𝐭 code. Okay, day 20 𝐂𝐞𝐫𝐭 code, and there let's develop a very basic Node.js application. Let's use the npm node package manager library, which you already know. I don't have to explain again. Npm init. So what it will do is it will create the package.json file. So whatever. So it is asking all these things. That's fine. Yes. Okay. It created a package.json file, and I do have this package.json file. And here what we have is we do have like just a second. Okay. So to run any kind of like to run any kind of okay, as of now this is fine. Okay. So what it is saying? Main is index.js. So let's create another file index.js file index.js, and here we are probably will be writing our code. So in our case also I will not write the code myself. So let's imagine we are using the Express package, Express hello world maybe, and you can find the basic code here. You already know this code, but just I'm copying and pasting it from here. And here it is actually using the Express library and instantiating it, running on port 3000. And we do have this particular API. So whenever this particular application will be called without any kind of like route, it will be actually calling this particular route, and it will be actually sending this message in the output. So let's imagine this is the message, or maybe I can just put the message in a better way in a JSON format instead of putting it into a text format. So what I'll do is I'll be just saying response.json, and what you can do is we can actually put a JSON output. Let's say the JSON output is a Node.js, Node.js. Okay, whatever. So this is what. So when this particular route will call, it will actually print in the output, hey Node.js, hello Node.js, whatever. So this is what, and to run this particular component, how actually we need to run. We need to have the package.json. Inside the package.json, we need the Express module as well as a prerequisite, right? So and one more thing, we need to also put it there in this package.json. So as because I wanted to use this particular script to start my application, so I will be using the start command, and here I will be saying node index.js. Okay, .js. So while I'll be actually firing this particular command from my command prompt, command terminal. So my Node.js application will start running, and it will give me the output. Okay. So I save all the things, and as of now, what I'll do is I'll be installing the Node.js component. So the dependency is the Express, right? npm install Express. So it will actually add the dependency of Express in my package.json. Now added the latest version of Express, and I do have the node modules also in my project. So now I'm quite ready to actually run this particular application. So before moving into the Dockerization concept, first of all, let's see how it runs, right? So we actually have put this in node index.js as a start script. So let's use node index.js. So it is listening to port 3000. So if I will be just going back and opening the local host 3000, it is giving me the output. Okay, Node.js, very simple. Now the next point is how to make image out of this particular component, particular application, and run it as a Docker container, and then we'll be actually pushing the Docker container or image into the registry so that others can also pull it. So that is the main purpose that we have now. So let's focus on our purpose. What we'll do is, so for that purpose, you can see here. So the first thing that we need to do is we need to create the Docker file, right? So how to create the Docker file? Let's first see it. So to create the Docker file, we need to actually create a file name. Let's imagine, like, let's go inside the project once again. I'll be creating another file. So Docker file. Okay. So whenever you are creating a Docker file, so you have to give the same name and in the similar format. And you can see this particular Docker icon is also coming up here automatically. So there is no extension, only Docker file. And in this particular Docker file, so there are certain syntaxes that you need to understand. Okay. So now the first line that you need to put it here, or first command that you need to put it here in the Docker file is the from. So from means like whenever I'm saying I wanted to run my software as a container, so that means if I go back to my explanation here, that means I need to put the OS application layer. Okay. So let's say I wanted to run the Node.js, right? So I need to put some kind of like OS application layer, maybe like that can be Nginx, or maybe like that can be Ubuntu. So on top of Ubuntu application layer, I can install Node.js, and on top of that, I can run my application with all the dependency, right? So in this particular regard, our Node.js application is actually running. So when we are not using any Docker container concept, our Node.js application is running in our local machine, and our local machine OS is, in my case, it is Windows. And on top of Windows, I already have installed Node.js. That's how I am able to run it. Because if I just see, I control C, if I just see Node, you can see I already have installed Node.js on top of Windows machine, Windows OS, right? The Node.js version is v16.16 for Node. Okay, so that's how I'm able to run this particular application. But let's say you wanted to run as a Docker container, there you need to define everything. Okay, so what is the OS component, and on top of that there is our dependencies, and then everything you need to put it there in the container. So that's where you need some baseline image. Okay, so baseline image on top of which you can build your component, software component. So what is the baseline image? So how you can define the baseline image? So let's first understand now. And for that, I will be just moving back to our Docker Hub. So if you go back to the Docker Hub, here you can search Ubuntu. You can search anything. So you will see. So these are the baseline image that you have. Let's say like Ubuntu or anything else. Let's say like Node.js, okay, or let's say anything, okay, Java Spring Boot or anything, right? So you will see the base image is already there in the marketplace, be it like Docker Hub or any other registry. People already deployed those kind of like base image, uh, so that anyone else can pull those image, and on top of that they can build their own application component. Okay, so in our scenario, what we will do is we'll also use the base image. So our base image, we can use Ubuntu as a base image, and on top of that we can use another base image like Node.js or something like that, and on top of that we can write our code so that it will run inside those kind of like software stack. Okay, those kind of like software stack. So Ubuntu, Node.js, and then our application. But we will be using a node image itself. So let's say I'm just going into the node image, and there itself will use this particular node image. And if we go inside the tag, so there are different versions. Okay, so there are different versions which can be identified with with the different tags like latest or slim or anything else, hydrogen and other versions. Okay, so let's say like we will be using the slim version. Our requirement is very simple. That's the reason we can use slim version here. And if we go inside the slim version itself, you can see Node.js slim version as well. Node.js slim version, it is actually using, one second, battery is low. Hold on. Okay, can you hear me?
Yes, Partha.
Okay, so you can see this particular Node Slim version is also based on this particular OS. Okay, so when we are we'll be actually using the Node Slim version. Automatically, Node Slim version is based on this particular OS. Okay, so what we'll do is we'll be first going inside the Docker file, and there we will be using the from command, and we'll be using Node Slim. So if you just click here, Node Slim version. Okay, so where from I got it? Like I already show you. This is the place like Node. Node is my base image, and I'm using the Slim. Okay. Okay, let's move little fast, and then we need to define the working directory. Okay, so while we'll be putting this particular image as a container, so running as a container, so we need to give like where actually all our software component or all our files will be residing. Okay, so we have to define the directory. So work directory as, let's imagine as of now app. Okay, so this is inside our Docker image. Okay, and then what next? We need to copy all of our component which we have here in our local project to this Docker image directory, right? So for that, there are some good ways to actually copy it. So the good way to copy the things is if you copy the package.json first, and later one, whenever you will be actually reinstantiating your container, so it will not reinstall all the component. Okay, so actually it will actually hold as a cache. So your package, all the packages will be hold as a cache. Okay, so that's the reason. First, we will be copying all the component from our package.json. So like this, and we'll be putting inside the application folder. Okay, of our Docker Docker image. So we are copying the package.json and putting into the application directory, app directory, which we have already defined as a working directory of our Docker image. And then we'll be running npm install. So as because you already have the package.json in our Docker image, we can use the npm install command to run it. And then we can also copy all the other component like index.js, or if we have other component, we can copy it. So we can copy it something like this. Copy all the component. All the component means like dot from the source, and we are putting target as application. Okay, that is our Docker image. And then going further, so what we have done is we have actually used the port 3000 and we have hard coded it here. So ideally, while we will be running as a Docker image, we should not hard code it, right? The things should come from the environment file itself, right? So if you have observed in our Cloud Foundry, we used to have those ports coming from the VCAP service itself. So similarly, also we can do here as well. We can also define the environment port. So we can also define the environment port. Let's say like 8080, and expose the port. So this is the internal port where we'll be having our software. But to actually access our application from outside, we need to expose. So we can have a different port for expose as well. But let's imagine we are using the same port here. Okay. And here I think like the syntax is port equal to. And then the last command is, so like we have done the execution previously, node index.js, right? So similarly here also, after having all the component ready and all the configuration ready for your Docker image, you need to also give the Docker image the command by which your application will start running, right? So for that, we will be giving the command like this. We'll be putting it like this. The command like here npm, what is that? npm or node npm start. Okay, fine. And that's it. So this is how you can convert your application, and it will be ready as a Docker image. Okay, so while we'll be building this particular project, it will actually create a Docker image, and then we can run the Docker image as a container. So we'll be seeing those things, but as because we already have defined the port here itself as an environment, we need to also change it in our index.js file, right? So how to change it? That is also very easy. So instead of having this, you already know, constant port. Let's say here the process dot env dot port, and if there is no port in the env, so we can also do it like this. First of all, it will get the port from the environment. Try to get the port from the environment, and then it will run. And rest of the things will be similar. Nothing, no, there is no change. That's it as of now. And now the next part is how to actually build your image now. How to actually build your image, right? But before building the image, we do have this node module, and we don't want it to have this node module in our Docker image as well. So for that, we can actually create another file which can ignore this particular node module while we'll be actually putting as a image. So similar to this git ignore, we can also have docker ignore. Dot docker ignore. Okay, you see here ignore. Yeah, docker ignore. And inside that, what we'll do is we can actually have like node module, right? So our module node underscore module. So it will actually ignore the node modules while actually building the Docker file. Yep. So that's it as of now, and then we can actually move ahead and actually build our image, first image. Okay. So what we can do is, so from here as well, so we can check, we can log in into the Docker or not. Login, Docker login. Authenticating with existing credential, as because I already have installed the Docker desktop and there I already logged in as SAP BTP training. So that's the reason it will automatically give me the access from here as well. Okay, so my system already know like what is my Docker desktop. So as of now, let's see what are the components that exist in the Docker, my Docker desktop, or images. So as of now, you can see I do not have any images. Okay, you can see it from here in the GUI as well. I do not have any images. My images, local images are empty, right? And obviously my containers are also empty because containers works on top of the images. So like this, you can check, or even like you can, if you wanted to check the images. So if you wanted to check the different containers of the images, you can also check with this command docker ps. So these are the commands probably you need to keep in mind always, like docker images, docker ps. So docker images gives you all the repository or images. So docker ps will gives you all the container which is running inside your Docker desktop. And then to build your project as an image, how to build it? So for that, we do have the command docker build. docker build -t, and then -t means tag. Okay, so then what is the tag that you wanted to use? Let's see. If you go back to your Docker Hub, you go your profile, my profile, you have to use this particular profile name, SAP BTP training. Let's use the same profile name while building it. And sorry, so SAP BTP training. SAP BTP training. And if you have observed the other images, they also have similar thing. Okay, so in my scenario, as because I wanted to use my own Docker Hub, that's the reason I'm using my profile name / whatever the name you wanted to give. Let's imagine in this particular scenario. Let's imagine in this particular scenario. So let's imagine like ACG node. Okay, ACG node simple, whatever. ACG simple node or ACG first Docker. Okay. ACG first Docker. This is the name that I'm giving, and also I wanted to give the version. Let's say like I wanted to give the version as 1 dot on dot or 0 dot whatever. So 0.0.1 whatever you wanted to give. I'm giving 1.0.1, and then you wanted to give the path of your project. Just understand clearly, okay? So then you wanted to give the path of your project. So our path of the project is the same path where I am actually building it, right? So this is the same path. That's the reason I am just putting dot. And on top of this, what will happen is it will actually build my Docker image. Invalid argument here it is t tag flag invalid reference format. Repository name must be lowercase. Okay, repository name must be lowercase. Okay, that's fine. ACG first. Okay. What it is doing, you can see. So it is first of all pulling all the baseline images from our node slave, and then one by one it is actually executing my Docker file. Observe from the from command, and after executing the from command, it will do other execution of the statement. Okay, so my image should be ready. So what I can do is I can directly go here and I can check. Sorry, not here. I will be going to the Docker desktop. So I can see ACG first Docker. This is the image. I got it here, and it is unused. And the size and other things, the tag or other things and other information, you can check it from here. And the container, obviously, there is no running container based on my image. That's the reason it is saying unused. And what I'll do is to run this particular thing. What I can do is I can actually run it using the command docker run -d -p, and then the local our laptop host port. Let's imagine we wanted to run in our laptop in, let's say like the here we have given 8080, right? So 8082. Let's imagine, and the Docker container port is 8080, and the image ID. So what is our image ID? So we can actually copy it from there, or you already know this. From here we can copy image ID is complete image ID with our versions as well, with our tags as well. I'm just putting it like this. So I'm saying Docker run detach format. Okay, and we wanted to do the port forwarding. So detach format means like whatever I wanted to have less overload from whatever the command I will be running, and then the port forwarding means like the Docker image port is 8080, which can be forwarded to 8082, by which we can actually access our application from our local system. This is how we can actually run. If I will just execute it, and after that, ideally I should be able to access my application using the 8082. So let's go and try to access our application using localhost 808082. So you can see it is running successfully here Node.js. So now if I just go and check in my Docker desktop, you can see previously it was unused. Now it is in use. Okay. And if I go in the container as well, there is a container. Here it automatically creates a container based on my image. Okay. So as because I actually given the command to start my image or run the image, it is running my image as a container, and you can see here 8080 is the original port, my image port, and it is running the 8082 as a local host port. And then I do have this as a running component, and I can go inside here. I can check the different logs. If there is some issue, you can check it from here, and then you can also inspect. You can also go to the terminal. Can also check the different files. Let's imagine like I wanted to see like what are the component I have in my container. So I can also go to the files and I can also go and check like, okay, so these are the index.js file that we have written. If I will just double click, you can see these are the things that we have written there in our file, right? So in our project file, project directory. This is the things, this is how you can actually deal with your images and container. And now, as the image and container is running in this Docker desktop, so let's imagine the same application I wanted to give it to you so that you can pull it and you can straight away run it, or maybe you wanted to do some modification, or maybe like you wanted to use this particular image as a base image for your project. So let's say you wanted to use this as a base image. So instead of putting this node slim, you can directly put my image. My image name is, this is the image, right? SAP BTP training SG first Docker 101. So this is the thing. If you put it here, you will have all the other dependent component like the node claim or Ubuntu, whatever the component is being used to build this particular image, you will be automatically inheriting. So this is the concept. You can directly use it. You can directly actually use this particular image as a base image, and you can build your own component as well. Oh my God, I have not saved it. But anyway, so that's the point. And now what we will do is like, now next thing, as because I wanted to give this particular image to you, how I can give, I can actually put it or push it to the registry. Okay. So the remote registry, how I can push it. So first of all, before pushing, I wanted to check what are the registry I have here. So if I will just refresh my page, hub.docker.com, SAP BTP training. And here, as of now, I do not have that particular image because I did not push it. So all the images I push it like 7 days, 6 days, 6 days, and 3 days ago. Okay. So let's push it, push our image to this registry, Docker registry. So for that, again, I will be going to this Visual Studio Code, and it is coming. And what I'll do is I'll be actually putting the command. I'll be just giving the command docker push and the same image. Docker push and same image. as because I logged in already to my Docker hub. With this particular command, it will push to the remote repository or remote registry. So you can see it is preparing, waiting, and ultimately it will also push it into the remote repository and registry. Okay, so it got pushed successfully. Now, if I will be refreshing again, I should have that particular image in my registry. So you can see ACG first Docker, it is coming up now, and it is updated a few seconds ago. And now anyone can actually pull the image. Okay, so as of now, you can see there is no pull. So if I will be pulling this particular image, I will be seeing the numbers here as well. So as many time as your image got pulled, you will also see it from here as well. So how to actually pull the image? That is also very easy. So you can also go and actually pull your image. You can also pull your image. All right. So how to pull your image? So for that, what you can do is, let's say like you are going back to the images, and as of now, I do have this particular image, and hub also I should have that particular same image. Hub means the repository. Okay, the repository here also I should have that particular image. So okay, so SCG first Docker. This is coming in my hub as well. Hub means like the remote repository. So I can directly come here and also pull it from here as well. Okay. So or maybe Docker pull and that particular image name. So what I'll do is, first of all, I'll be just deleting this. Okay. So before, so it will not be delete. So it will not allow me to delete because the similar thing. So the container is running on top of the image. So first of all, either I need to stop it or otherwise I can delete it. So let me just delete the container first, and then I can come here and I can delete the image, and whenever I want, I can come here to the hub, or I can go to the command line and I can use the Docker pull the particular image name or image ID. So like that, if I just go, and this is my ACG first Docker, I can pull it. Yeah, it got pulled. So you can see now I do have the same image in my local directory. You can also pull the same image from your Docker desktop as well. Okay. So otherwise, let me just pull it from. Let me just show it from this one as well, so that we can also pull it. So how we can do it? Docker pull the same image name. You will see the image is coming here. Okay, so the image is now coming in my local Docker desktop. This is how you can also pull it, as because it is open to all as of now. So, but in your actual project, maybe this is not the ideal scenario. So while creating the account in this Docker Hub, you will have two options. So one is the private option, one is the public option. As because I'm using the free version of it, I need to put it into the public repository or public registry. Okay, so that's it from the basics of Docker. But some more thing I wanted to just show you or explain to you before moving into the next topics. So the next topic is some of the other component of my topics are okay. So okay, let me just quickly explain what are the other things that you can do while learning the Docker. Let me just show it to you. So as of now, what we have done is we have done the Node.js application, and we have created an image out of our Node.js application using the Docker file, and then we actually run our Docker image as a container, right? And even we have pushed it into the Docker Hub as a registry. And some more component that you need to keep in mind, as because as of now we only deal with the web application. Okay, so there could be some scenario where you need to deal with the database. So where we will be having the volume concept. Okay, so volume is something like, let's imagine your container is container got crashed, or maybe like you need to restart your container, right? So and if you have your database running inside the container, your all data will be gone. So that should not be the ideal scenario. So for those kind of scenarios, you need to use the volume. So we'll be understanding volume some more details in subsequent sections. But as of now, just imagine to have data persistency, you need to use another component, that is volume, okay, inside your image. Okay, so that is one thing. And now another thing is like whenever you will be building your application, there will be different microservices. We can have the application, okay, so we can have like the like this. So we can have the service, we can have the database, and the service and database should talk to each other to exchange the data, right? Whenever it will be requesting, like that, right? For that, we will be using the Docker Composer. So we can create a Docker Composer YML file, which can actually hold the different information, config information for different services, and we can also link or attach different services, right? So let's imagine like in our YML file also, there also we, so let's say this is the SRV. So if you observe in our manifest file, manifest.yml file or mta.yml file, in our CAPM applications, there also we have the YAML file which holds the deployment descriptors, which can hold the different information of the different microservices, and also we can attach the different microservices together. Let's say like by microservice SRV needs a destination microservice, or like in the connectivity microservice, right? So as a backing microservice. So those microservices needs to talk together, right? So let's imagine the similar thing here as well. So we can also have a database, which is also kind of like another container, maybe, okay? Inside another container, these two container should work together. And as you are learning, so let's imagine like inside a particular container, you should actually use a particular purpose, okay? You should use a particular container for a particular purpose. That means you should actually divide and independently run your different software component into different separate container itself to have the microservice based architecture. Okay, so that's the thing. So here basically, so volume we will be using where we need to actually deal with data persistency, and Docker Composer.yml, where we need to actually give the different component the configuration to talk to each other, right? So that's how it will work. And as because this is also a container, okay, so let's say like this is also a container, this is service container, this is the database container. And as because service container is fine, okay, it can restart, it can crash, and you can also replace it, this particular container, with a new container. But if this particular container will be crashed or restarted, the data will be gone. For that, we need to attach a volume, so which can persist the data. So that is the concept. Maybe like going forward, you will be seeing more details about it. But let's move forward. How to actually deal with this volume and Docker Compose.yml. Okay. So for that particular purpose, what I'll do is I'll be also creating this Docker Compose.yml file in our project. Okay? So if I'll just go back to my project once again, I'll be creating one more file, that is Docker compose.yml. So in this particular Docker compose.yml, automatically you can see the icon is also coming here. Okay. So if your format of the file is correct, the icon will also be coming automatically. So inside this particular file, what we'll do is we'll be actually giving the version. So here, let me just move it little fast. And for that particular reason, so what I'll do is I'll be copying some of the code. So here you can see I'm just giving the version, the service. Here the web service is my web service will be running, is running the 8080 port, right? As we were actually defining our Node.js application port as a 8080. So in our Docker file, right? So that's the reason I'm just putting it here, and then we are putting another image. So here saying like, okay, so I have all the local files or the application files available in my folder, in my local folder itself. That's the reason you can build it directly from there. Okay. So if you remember, so to build our Docker, we have used this Docker build, right? Docker build -p the tag, and this is the tag name. So like this we have built it. And while we'll be using the Docker compose, we are giving like build the same project directory, okay, with this particular port, and expose in the same port itself. And here we do have another service, okay, so which we are using another image, MySQL image. So MySQL image, for MySQL image also you can search it from here. This is another base image that I'm using here from the Docker Hub. So Docker Hub has everything, every base image, okay, and based on that you can also take it like Docker pull MySQL, or in our scenario, because I'm using the Docker Compose, I am using MySQL as my image, and I am using the environment, some environment details and volume details and all. But our main intention is just to show you, okay, how it actually works and how we can deploy it. That's our main intention. So as of now, just keep in mind these things. That's fine. And what next? So how to actually deal with now this with so how actually now we can build with this Docker Compose and have multiple container, as because you can see here our intention is to have multiple container. One container is for web, another container is for database, okay, and uh, then we'll be having two container as part of our Docker Compose. So let's first check, okay, how it works, how it will deploy, and then we'll see the details. Okay, so that's it. And what next? Next is how to actually deal with this Docker Compose. So what you can do is you can actually use Docker Compose up, Docker Compose up. This command. You can see it is handling the network, handling the volume, handling the container, everything. Now, so example app listening on port 8080. So if I will just go back, okay, if I'll just go back to my Docker desktop, let's see how it goes. My Docker desktop. Where is my Docker desktop? This is my Docker desktop. So now, if I just go to the containers, you can see I do have this a Cloud Guruji code, and I do have the database and web. So like this, you can use the Docker Compose while you will be dealing with multiple container. Okay, so I think like as of now, this is fine to understand things were actually running, but that's fine. So my intention was to give you the clarity on the basic component so that while moving into the Kubernetes and Kyma, you have the baseline, have the strong baseline, or at least like you have the understanding of the basic component. So that's it from our section on one of our today's session. So I'll be closing it now, and next we'll be starting it right away. But I'm closing it now for this, okay? Because I think the sessions are this particular session is going little long. So let's close it here. Then we'll be starting the Kubernetes concept. Okay, as of now, we have learned container, we have learned Docker, we have learned how to create the Docker image and pushing into the Docker hub and all those kind of things we have learned so far. Now let's move into the Kubernetes concept, or Kubernetes based design, and why we need Kubernetes, how we will be implementing Kubernetes. Those are the things we'll be learning in our next section. I'm stopping the recording as of now.